Λοιπόν, καλησπέρα και από μένα.
Okay, good evening. I know I'm the last speaker, so I need to thank you for your patience and for your participation, of course. We're going to deal in this last presentation with a burning issue. When we talked about it with Akimon, we did not have the train crash yet. But after Tempe train accident, there's been a topic going on about tunnels and all the demons rised. I'm not going to talk about it any further because there are going to be too many questions and too many issues we cannot actually answer to right now. But in any case, this presentation touches upon many topics, and all of you that are dealing with tunnel safety will only lose your sleep over it. Right now, we do not know how, as a fire service, to deal with such incidents. And I'm saying that knowingly. If, for example, we wouldn't be able to prevent this accident, but it took place 1 or 2 minutes afterwards, then it would have taken place in one of the largest tunnels in the city. And apart from all the phenomena inside that tunnel, all the people would not be able to receive any help because there wouldn't be any way to reach them. So right now we have tunnels in Greece. There is one, the biggest one in the Balkans, in Kalidromo for the trains, where there is no access whatsoever. Whatever may happen in there is between the train and the mountain. So you do understand that such an incident taking place within the tunnel of Tempe, we wouldn't have any access in order to help these people. And now what kind of help would be able to offer? Recovery of dead bodies. So now we'll see that in our country we have an approach over the incidents as any other case. You know, as with the electric cars, sometimes we know the causes of the fire, we analyze the ways, but we cannot find ways to deal with these incidents. This is from a road tunnel. You have domino effects, and you can see how they develop unexpectedly. You can see a collision taking place, and suddenly here you have a tank truck, and here you have a smaller car with dilution with solvent. So this does not stop here, though the car back stops apparently. So I started with this video in order to show you that we deal with incidents in the tunnels as in the case of some apartment in a densely populated area, as we deal with an industrial fire. But tunnels are different, first because they don't have access points, because we cannot create access points, because the tunnel can have a certain ventilation according to the manufacturer. And slowly, let's see. This presentation, which is quite heavy, I'm going to try and talk it through. Please keep your questions for the end. I'm sure there will be concerns and questions for the end. For our friends coming from abroad, so from the two people in Germany, I know that you have such experience for many years now in the tunnels. In Ireland, a couple of years ago, we had an IFS exercise in Switzerland. We've had two Irish who went to Switzerland to be trained about tunnels because they have one underground tunnel of 200 meters and they came to be trained for that. We have many kilometers of tunnels, but I don't think we have received the right training. So, generally speaking, when we're dealing with a tunnel, a big project, we have problems of fire protection and fire safety, operational issues, since we need to see these topics differently. And then we have training issues. What do we mean training issues? It means that we need to have materials, means use them accordingly and not as we've learned from the past. Tunnels are a very particular environment with the characteristics I mentioned earlier. Through this process, from the experience of Europeans on tunnels for over 200 years, we analyzed problems of the daily use of the tunnels. So we tried to have the right safety equipment of this infrastructure and to see the behavior within the tunnels, because the problem is not the rescuer, but is also the behavior of the people driving or entering the tunnels. They don't know how to drive in a tunnel or what to do in case of a problem. So we try to see what is the analysis of strategical interventions. We've seen there are many problems in the tunnels. We cannot treat them with these common fire service tactics. So we analyzed various accident scenarios. In the firefighting, we learn from analyzing accidents. So we've had two regulations that resulted from that. These are the two regulations, and we built everything that has to do with tunnels on those two regulations. They are dealing with the minimum specifications about tunnels in the inter-European network, and the 96 of 2008, which is about the means for road tunnels. But what is such a fatal accident as the one in Tempe? It's what we call TAME or VAME. These are technological accidents that are quite expanded, quite broad. They are difficult to manage. They expand over a long area. They may go over administrative limits or even operational limits. We may have a problem or risk with the contamination of the environment due to chemical or biological agents, and we may have the domino effect with damages that can be direct to people, infrastructure, or indirect to the underground aquifers, horizon, or the surface. So we have even ecological catastrophes that may occur due to industrial accidents with impacts being collapse, explosion, whatever, various accidents. And the last are transportation accidents, meaning road, rail, sea, air transportation accidents, etc. So we divide them in these three categories of accidents. because they might be a combination of various factors that lead us to such an accident. These may be some deficient construction or design. So when we designed a building or an infrastructure, we did not foresee factor X that led to the accident. That could be also a problem, a deficiency in the management during the operation or during the accident. Well, does that ring a bell? Maybe it rings a bell to everyone about insufficient management. And then finally, we have a terrorist attack. And when we have such a crucial infrastructure, we save them from such, we safekeep them from such a factor. So what is the technological accident? We could perhaps qualify it in a way. My question, and I'm sorry for the question, having heard all the previous presentations, about data that we heard yesterday, we use data in a way if these are real data, meaning that there is a way to collect, a way to manage them, and they should not be very subjective about what anybody can collect and write down. So we wanted to specify what is a technological accident. It's an accident that can cause more than 25 fatalities or more than 125 injured. Finally, there may be a need coming up to evacuate populations or to mobilize populations. All that is part of the technological accident. What are the sectors that can lead to this human-driven big catastrophe? It is a bigger scale infrastructure, dams, public buildings, bridges, highways. Then we have mass transportation and, of course, industrial production of combustible materials. These three sectors are connected within a tunnel. Why? Because I have one infrastructure of a big scale, and what do? I transport by road or rail, and I transport not only people, but only hazardous material, combustible material. So these are factors, three factors of the technological incidents within one tunnel. Do we know how to manage them? I guess not. So let me tell you the technological accidents with regard to transportation in 2010. We've had 72% for road transportation. Rail, you see a very small percentage. Sea, 14.1, and aerial, 10.4. So we have the biggest problem with the road transportation. Same thing in this graph, we see the yearly increase of road or transportation accidents. We see that industrial and coincidental accidents remain the same, but we have a peak when it comes to transportation accidents. Why? Because we do not travel at the same pace as in the 1970s. Now we go to London, have a coffee, and come back. 20 years ago, London was a 1-month trip if you wanted to have it. So let's see what led us into seeing things more holistic, in a more holistic way. The accidents that we had in the recent years, fatal accidents, were the one in Mont Blanc in 1999, Tower in the 1999 again, and St. Gotham in 2001. And therefrom started this whole doctrine for these two directives about how to set up tunnels. So the fires with specific characteristics within the tunnels and we need to forget anything that we know with regard to building fires, is that first of all we have to do with big heat, because we don't have couches in the tunnel and chairs and tables, but we have machinery, cargo, and fuel. So we have a big load. And then there's radiation, because this is closed area. We have radiation from what is in flames and from the rest. So there's radiation everywhere. And you also have irritating and contaminating materials, and you have less oxygen and less visibility, reduced visibility. It's a closed area. We ventilate it in a certain way, so anything within it has been burned, and there is no visibility. So consequences for the people, and I'm not talking about firefighters, but users who are trapped in there, have to do with reduced visibility. And you may say, so what with that? But many victims, as we'll see in St. Gotthard, were people who could not find escape exits. Due to the toxicity and the suffocating gases. And finally, the heat, increased heat that kept increasing very quickly. Designing tunnels. How do we design tunnels after everything that we analyzed so far? We must take certain factors into consideration in order to design the tunnel. We need to analyze everything and see how to deal with it. It's not just about showing what the problem is, but we need to find solutions. So what are the characteristics of the circulation, of the traffic? Does it take a big load of traffic within a day? Whoever takes Attiki Odo from 8 to 9 in the morning, you'll know that these are peak hours for the tunnel of Vrilisia, which is an uncovered tunnel of a different shape. You have congestion. It's not the same with the tunnel in Lamia area. And then the length of the tunnel. How much time is it necessary for a car to cross that tunnel? So the length is also important for this equation. Then the type of traffic. What does that mean? In Greece, we're very happy so far because most tunnels have just one type of traffic, which is one direction, unidirectional traffic. In Europe, it's bidirectional, and they have more problems. But now we have separate tunnels with one stream of circulation. I think the only exception is the tunnel in Karpenisi area, and maybe one or more, I don't know, that I keep forgetting, or older tunnels. So new tunnels have one and only direction. This solves a lot of the problems that we're going to see. The geometry of the tunnel also is important, and I'm not talking geometry if it's round or semicircular. But if within the tunnel we have ramifications, or if we have turns, etc., most the tunnels in the country, if you go to Thessaloniki, for example, you have at least 2 or 3 different smaller or bigger maneuvers to make within the tunnels. And finally, the number and the type of heavy vehicles going through these tunnels. So we have tunnels where it is allowed to transport hazardous goods, and others where this is not allowed. However, many hazardous goods go through these tunnels without being controlled, either because they do not classify the goods they carry as hazardous, or because they consider that the tank is empty. Does this work? I'm not going to insist very long here. It's the butterfly Slido, and it says that if we analyze, if we do what the minister said, about risk analysis when we have a fire to know how to move, etc. If we put a crucial incident expected to happen in the tunnel, we're going to see whether we believe it's going to be successful or if it's not going to be successful, and things will have a negative impact. So we can put here the initial causes, then have a sequence of coincidental events, and from the various errors that may occur. Then we can go to the ramification of facts, where we will have influences for the environment, for people, for infrastructure, for services. So this butterfly plan analyzes causes, results, the accident itself, and the outcomes. So this is what resulted from this butterfly. It's the circle of destruction. And we are always in the first case, where we have designed everything. We believe that our plan is the best. And then at some point we understand that we have forgotten something, or that there is something more that we have never predicted. So we have three areas. It's before the accident, during the accident, and after the accident. The three areas in this disaster plan. And we use that at the same place that we design and redesign. In the first case, we need to evaluate, to assess the risk, and assess the risk within the infrastructure. Then we need to try to prevent and mitigate the risk using fire protection means or training people, etc. And then the readiness for urgent emergency cases. Is there any structure that can be covered from a certain specific service? For the tunnels, yes. There are units that safeguard this part of the tunnels, but for the railway tunnels, no, and we'll see why. Let's go now to the duration of the accident. Do we have rapid intervention procedures? In how much time can we reach the place of the accident, the incident? 10 minutes, as somebody said, is too much for when we have a fire. I think it's you, Kimon, who said that. 10 minutes is a long time. Will we be able to reach a tunnel within 10 minutes? Will we be able to reach the tunnel sometime? Because it's not just to reach the tunnel, but we need to reach the incident itself. So within a tunnel, we have a multiplication of problems, multiplication of the time, and the time when we can engage. So we need to redesign all the procedures. And I open a parenthesis here and say that in many cases, in tunnel exercises, in tunnel drills, we have overturned two cars within a tunnel, and we access the tunnels in front of the cars, and we solve the problem. But I don't think that this will be the case all the time. And finally, having finished with the accident, then we need to see what happened, how to evaluate the errors made, how to estimate the situation, and then redesign, start over and see what did we miss, what was not part of the equation, and what was the mistake made. So we start from the scratch. We need to start over with the assessment. So this is the cycle of disaster. It's international, and all advanced countries exploit that or utilize that, seeing an accident as an opportunity to improve and not as something that has to finish quickly. And what can we do? Bury it and just go on with our lives. So let's see very quickly the whole process of assessing, first of all, the risk or the hazards. In Greece, risk, hazard, danger, all the words are the same. All the terms can be used equally. It's when we say in fire protection, we mean security and we mean safety at the same time, but it's not the same thing. It's two different things. So, what about this hazard? It's a dangerous phenomenon or product or situation that can lead to loss of lives, injury, or other impact on the structure, on health, material damage, etc. So, we need to see what is the factor that is life-threatening. We have here the combustion graph, so it's easily understood to everyone, because hazard has to do with the size, how big this factor is, the duration, and the speed of onset of the accident, of the incident. So this has to be measured, assessed, and then dealt with. Furthermore, we have the risk. What does that mean? It means that I've taken various ingredients. I have here the factors of hazard, of exposure. How am I exposed to this risk? Which way? And vulnerability. Maybe you haven't heard it before, but it has to do with what happens to us firemen. We are vulnerable vis-a-vis what we are dealing with, and any safety measure that we take from our protection means that we wear or materials that help us put off the fire are there to help us reduce our vulnerability. So with all that, we know how much or what the degree of the risk is. Now, how do we deal with this risk? There are various dilemmas here. We may have to be ready to pay in order to prevent this accident. This means constructors, designers, users. Mr. Chubb said yesterday that we have no money. There is no money. And this is the reality. If you don't have any money, you cannot deal with this risk. You just try to cope as much as you can. Let's go to the second part. How much risk can rescuers undertake in order to save people, to rescue people exposed in the tunnels in a very dangerous zone? And this is about the police and firefighters and ambulances and volunteers, all the people who respond to such emergencies. And this does not have to do with how much I can undertake because I'm courageous and I just go in there. The risk undertaken has to do with the means and the training that I have in order to deal with that risk, that level of risk. So, safety in road tunnels has an holistic approach.
What do we need to look at? We need to include in this approach the building materials of the tunnel. A tunnel that was built in 2008 is completely different from a tunnel that was built in 1998 because of the different means based on building regulations. The vehicles and the trains. I already said that we have vehicles covered by specifications and others that may circulate now but are not covered by specification. The operating procedures of the tunnel, are they there? They are, and they are governed by the operator and by the firefighting teams. And lastly, the users of the tunnels, the Greek drivers, are not trained to drive in tunnels. They drive in the tunnels in the same way that they drive in the open road. I have seen vehicles passing over trucks or whatever, and that's simple in the highway, but not inside the tunnel. Inside the tunnel, there's a different geometry. It's a different aerodynamics. So by simply overtaking a car, you can have a very tragic accident. So the drivers do not have this type of behavior, this type of driving behavior, or the self-rescue behaviors, as they are called. let's go to this part that has to do with the alarm principle, how we measure risk. We say that if it's going beyond some limits, it's an area where we can do nothing about. Unfortunately, most of the time, when they design something, they go up to point BC. There we have some risks that are specified and identified, and what we do is we try to find the means and materials, the techniques to mitigate that risks, but not eliminate it, just mitigate it, reduce it, and bring it at an acceptable level or a manageable level. And what you see is that the acceptable risk is undertaken only when there is a benefit involved. So if we look at the benefit from the use from the use of that means, then we assume the risk if the benefit is greater than the risk. But of course, we first mitigate the risk. Now, risk assessment and quantitative assessment is very important to determine the level of safety of a system, and some questions arise. What can go wrong? So within this whole area where we identified the risk, is there something that could have gone wrong? How likely is it to go wrong? And from this fault that will occur, what are the possible consequences? By answering all these questions, we are now going into the procedure of designing in a more safe manner. And let's go into tunnel design. I will go briefly I will give you some historical details about Greece in particular, because as I told you, Europe has many decades of experience with tunnels already. So what is a tunnel? It's an underground opening, continuous or not, in the ground. There could be changes, and the route is somewhat horizontal. Tunnels are used in railway and road networks. The largest tunnel is in Mont Blanc, a mountain tunnel, or we have the Tembi tunnel. We could be bypassing some geological phenomena. We had the tunnel in Tembi because the ground was loose and we couldn't have a road there, so we had to bypass the area in order to make it more accessible. Or we use them for environmental reasons, not to destroy ecosystems or forests. They could be used for urban transport systems, such as the underground train, the metro train. Or in Athens, we have a tunnel that's hundreds of kilometers long, if you consider the fact that we have three lines, metro lines as well, and we will have more in the future. And again, I'm not sure if we could handle a very large-scale event if it were to happen in those tunnels. I'm not going to stay more on this slide. These are the 10 largest road tunnels in Greece. First one being at Tempi, then Driscos, which is what's the road at the Ionia Highway, the tunnel of Panachopoula at Olympia Odos, and so on and so forth. These are tunnels with a length over 4 kilometers, each of them. Now, the characteristics of the tunnel environment, these are the things that we need to analyze. They come from the spread of the smoke that reduces visibility, the increase of temperature, the existence of hazardous gases, dangerous gases, such as carbon monoxide, etc. Now, the conditions that can develop inside a tunnel is the piston effect. We have an accumulation of vehicles behind the scene of the accident. This is sort of what happened with the railroad accident at Tempe. There was a piston that pushed the two trains to collide. And if you can think about it, this was an open environment, which meant that the train cars fell on both sides. So this mechanical energy was reduced because they changed directions, they fell on the ground, friction. But consider what would happen if it was a closed tunnel with no room for them to fall. This could have been all one mass. And if you also consider a phenomenon that was unheard of for us in Greece, the explosion. If you consider an explosion inside the tunnel, you can imagine what could have happened. We're talking about heat, temperature, and extremely high. Now, to achieve all of the above, and in order to reduce the risk, mitigate the risks at the tunnels, we have to go back and measure certain parameters, such as the length of the tunnel. That's a critical parameter. This is why when you go through tunnels that are less than 500 meters long, there is no dynamic ventilation. There are no turbines because it is considered to be self-ventilating. But over 500 meters, there's no dynamic mechanism, perhaps on a case-by-case basis, but we need dynamic ventilation there. This is why we use turbines. The number of branches in our country, we have an advantage because we only have one-way branches, one-way traffic. So we don't have two-way traffic in our tunnels. The number of cars in the tunnels, it's different, obviously. The geometrical type of the cross-section, the type of construction, if it's from concrete or from stone. All our tunnels in Greece are made from concrete. In Europe, you have also stone tunnels. There's one-way or two-way traffic. The traffic load per branch, per direction, is there a traffic jam or no? Urban tunnels may face congestion during the daytimes, or we could have seasonal traffic load. The time it takes the first responders to get to the scene, that's where things become difficult. What have we done to reduce this time? We have fire stations spread out on the highways in order to reach such points faster. So the time it takes to arrive is a very critical parameter. The presence, the existence of heavy load vehicles, the type of cargo, and whether or not it's hazardous, the characteristics of the access points, and we're mainly talking about the escape routes, the width of the road, and the questions of speed. That's a big question mark because you can also answer, do you follow the speed limits when you are traveling inside the tunnel? Do you know what the speed limit is? It's 80 kilometers per hour. Which car do you know that drives at that speed? Even the heavy trucks are going at 80, at least 80, and the passenger cars overtake them. So they're speeding a lot more than that. So based on the 2004 directive about the proper operation of tunnels, we have to ensure regular testing. We have to have training, the right equipment for the emergency responders. We have to define procedures for immediately closing down a tunnel when there's a case of emergency. Can we shut down our tunnels? Only with the lights. But there are some tunnels at Egnatia, those mainly, that are also equipped with bars. But unfortunately, some people may already go inside before the bars go down. Some people follow behind the accident. We have to have risk mitigation measures, and we have to have other new, we have to have a reassessment in order to establish further mitigation measures. So we have the same incident, the same case that leads us to three different things. So we have a fire. We have a fire in a vehicle inside a tunnel, which means I have flammable materials, the presence of an ignition source, short circuit, and oxygen. I have all of the ingredients to start a fire. The fire initiates, so this fire could develop into fire with little consequence, because perhaps it was dealt mainly by the user, the driver of the car, or the driver of the next car who used the means that the tunnel has. So it could be a small fire with little consequence, or medium impact consequence, or a heavy impact. And how do we measure that? Small impact is little or no injury and little damage to property. Some smudge on the walls of the tunnel, for example, nothing more. But if we have damage to property or injuries, we could have burns and material damage that partially interrupted the operation of the tunnel. If we go to a significant impact, we could have death or serious injuries and damage to the structure that kept the tunnel closed for many months until it is repaired. I'm going to move past that. We're going to look at it next. These are two tunnels like the ones we talked about before, two accidents in tunnels. There was complete total destruction of the trucks and the cargo, one in Mont Blanc and the other in St. Gotthard, where we had victims as well, fatalities. And what we are concerned about as firefighters is to prevent this thing here, meaning to prevent the collapse of the structure. This is why we say that we need to think outside of the box in relation to firefighting issues. Up to now, we learned at the CBT that we need to handle gases. If we see the fire, we have to attack it and put it out. When we have interventions at tunnels, we have to forget about gases, forget about the fire, and protect the structure. We have to protect this shell so it does not collapse and collapse on us or on the victims that we're trying to help and rescue. So in a fire that is developing, in order to describe it fully, its dynamics, we have to look at the variables, how the rate at the heat is produced, the rate of production of toxic gases and smoke, the size of the flame and the length of the flame, because perhaps we have a fire that, because of the materials, that the flames are not high, but it could be the opposite case. And unfortunately, such fires spread horizontally. The heat that is generated, the radiation, and the spacing of the fire, that is a problem. We need to identify the location of the fire. What do you mean by that? We need to identify at which point inside the tunnel we have the incidents. We don't have visual contact. In the Tempe tunnel, that is 6.1 kilometers, you understand that it is difficult to know exactly where the fire is. However, that's critical because, as we will see later on, that's the way that will help us intervene in a safer way and faster way and perhaps rescue people that are there trapped. Moreover, the type, the size, and the location of the ignition source, the spread of fuel, the distribution of fuel, the ventilation systems and the ventilation conditions of the tunnel, because we're talking about dynamic ventilation. And we need to be very frugal in how we use ventilation. And in most of the cases, that's not up to us. It's not up to us that we'll arrive there as responders. It depends on the crisis management center, where we supposedly need to have one officer from the fire service there to help take the decisions. And because ventilation systems are important, because they can trap us there. Now, external conditions, that mainly has to do with the wind. If there's strong winds outside, and especially in the direction of, along the direction of the tunnel, we could have issues with the dynamic ventilation that we're trying to achieve. The activities of the people that are involved, whether they are users or the staff of the tunnel or our manpower, interventions at the different systems of the tunnels, and the type or the packaging of the fuel material, the combustion material. So this is the fire in the tunnel. You understand that this is a condition where we are not really sure that we know what to do. Do we need to push the smoke from one direction, or maybe the velocity that we choose is such that it pushes the smoke or creates this back layering effect that we don't know where it's coming from, but it's the result of some bad dynamic ventilation. So we know that there's the flow, airflow. For us, this is beneficial because essentially we have one-way tunnels, which means that's helpful. We want to send the smoke towards the exit point because there will be no people ahead of the accident. Everyone that was ahead of the accident has already left. So there's no one inside. In contrary, when we have two-way tunnels, we don't really know where to send the smoke because there could be people ahead or behind the accident. So you have many problems in that case. Here are the procedures, is the process, the combustion process in a tunnel without ventilation, with limited ventilation, and with calculated sufficient ventilation, which is the case that we are after every time. The ventilation, when sufficient, will flood the entire tunnel. The smoke is going to flood the entire tunnel. With insufficient ventilation, bad calculated ventilation from the turbines, which pushes the smoke to one direction, but because of the velocity of the smoke, some of it is going back. So in the last case, we have a calculated way where we say that we want to push as much, so many liters of smoke inside this tunnel so that we can create a wall between the people who are trapped and the responders and help them reach the ignition point faster, access the point. In general, we have 69 incidents with fatalities internationally in terms of road tunnels. We had fires, individual fires, that is, fires in one single vehicle, and the fire did not spread to other vehicles. So the majority were 43 out of 69, and they fall into, out of those, there were 11 with no fatalities. On the contrary, the 5 out of the 69, there was a category that the fire started with heavy vehicles, and some of them had cost in human lives. In 7 cases, 7 incidents, there were victims involved in 5. That was just property damage. And in other 13 cases, there were victims in every one of those. So the categorization of fires in tunnels has to do with 2 things, property damage or the fatalities of victims. This is how we categorize tunnels. And let's look at the operational approaches. We have the typical firefighting strategy that tells us we're going to intervene either in an offensive or defensive manner, but the defensive or offensive attack has nothing to do with what we have learned so far. On the defense, we are outside of the building and we are throwing water. On the offensive approach, we get into the tunnel. Here, in this case, we need to get in the tunnel anyway, otherwise we cannot put out the fire. So once we go in, is that an offensive approach? Not necessarily. We need to use the part of the tunnel that's on the other side that is clean in order to attack the fire. So our operational tactic is always about the fact that we try to approach the incident, get close, and put it out. But in most of the cases, that's not possible to do in a tunnel. So an offensive strategy, the firefighting efforts have a priority. which means that if I have an incident inside a traffic branch in a tunnel that is developing rapidly for whatever reason,
Πώς εδώ. Πάτησα εγώ. Λοιπόν, για κάποιο λόγο λοιπόν πρέπει να...
So we have to intervene fast. So firefighting actions have a priority. In the defensive strategy, we cannot, for whatever reason, access the point of the fire. So we need to do search and rescue inside the tunnel first, because there could be people trapped in there. You can combine the two. In a tunnel, no, it's not possible, because it may not be possible to reach the source of the fire. This is why we cannot take an offensive approach. These are some examples where this is the key for everything. If we can be trained into understanding where the fire is and how can we access it from the near branch. It's impossible to get into the same branch for many different reasons, because of the distance, because there are cars stacked up behind, because of the heat. So it is important to know where the fire is and use the escape routes and other branches to get in. Same thing here. What have we used here? We have used, again, we have the ventilation. And we decided that we are going to enter from the back of the tunnel, again, from the other direction. Why? Because we don't have access in the main direction, in the main branch that we are looking at the fire. And the forces, the men that are involved, the services that are involved, should not go into the fire from the main branch or go through the opposite direction. Use this route in order to get faster, because this is what they will be facing, the smoke, and we're going to analyze that later. Now, if we're talking about natural ventilation, we are talking about a procedure where we have control of the air, but the structure is built in such a way and the accident is developing in such a way that we are immediately following an offensive strategy to reach our vehicle. This is a tunnel. We have such tunnels at Tempe, where aside from the ventilation, the dynamic ventilation along the tunnel, we have vertical ventilation as well. So it's impossible if you have a long tunnel to the sound was lost. In the booth, we have lost sound.
Ένα, δύο. Φτιάξαμε λοιπόν καπνοδόχους.
So we created smoke extractions in order... sorry, the sound is lost again.
Εντάξει. Λοιπόν,
So let's resume. So one may think ventilation, ventilation, ventilation. It will be burned. If we do not ventilate this tunnel, we will kill the people in there and we will never be able to reach the incident. So we need to find the golden middle to ventilate, to extract the smoke, and then see how to control the incident. International experience. Unfortunately, we have no experience with tunnels. We use them for 20 years now. We do not have an experience of incidents, which is a good thing. But the unfortunate thing is that with our first incident, we may not do that well. Our friends, the European and the international experience, well, they're still looking and analyzing how to deal with incidents in tunnels. These are two real incidents. St. Gotthard that we will analyze. It's the initial stages. Here we know that in case of an incident, the first 10 to 15 minutes are decisive for the rescuing of people and limitation of damage. And this is the result of this Enhongoham example because people, let's say, lived for about 20 minutes only. Up to 15, 20 minutes, these people were alive, but nobody offered them any assistance because certain things happened. So this is St. Gotthard tunnel. It's the left tunnel because the right one is the one that was opened afterward. In the left one, Swiss A2 highway, and it connects between France and Germany. It starts from Aiolo in Switzerland. You can see where it is, and it ends to Gossenen. I'm sorry for my German. There's a small difference with regard to the altitude. It's a little bit in ascend. So what happened in there? So totally, we have 844 accidents up to 2001 in this tunnel. This tells us that there is a load. People are mobilized. They take it. It's in Central Europe. We have goods coming and going. Most serious fires in these tunnels were in 97, October 97, where we had 8 cars transported by a larger truck. Then in September 97, was a bus that was totally burned. Then again, we had another accident in a 90 collision with a tank truck with many, thank God, empty gas tanks. And again, in 84, another tank trunk with commodities, very important damages. So up to then, we had some damages to the tunnel. But then comes this incident in 2001. What happens? 939, a Belgian tank car comes from the south entry of the tunnel. And in 1.1 kilometer from the entrance of the tunnel, goes into the opposite direction. I don't know, car fishing, sleeping, the driver slept. That means now that a heavy truck goes towards the south. 9:40, 1 minute after, we have the first alert from one smartphone within the tunnel to 112. But what happens? There is a fuel on the road deck, and there is a fire. 9:41. there is this tank load that has obstructed that entrance because it's very high and it blocks the entrance of the tunnel. So one mistake after another, we can't control things. 9:42, we have the fire detection system, ventilation system. So we knew exactly where the incident took place, and at the same moment, we have rescuers coming to Airolo, southern side, and then we had a fire to the other vehicle involved. 9:44. See how few are the minutes compared to our procedures and reactions so far. We have the blockage of the north exit. Police comes very quickly. They stop circulation. They stop all the traffic. 9:44, we start intervention. Forces from Airolo reach the incident, but forces from incident coming from north to south stopped due to smoke 2.5 kilometers away from the incident. So these people are no longer useful. The load is upon the shoulders of one crew. So what happens at 10:28? We have the collapse of the roof of the tunnel on the tracks. So collapse of the tunnel, that means that we lose any putting off process. So we had this frontal crash of the two trucks, one mainly with photograph material and clothes, and the other commodities that were car wheels. So these two trucks had a big thermal load when the fire started, and why we had this quick spread of fire and smoke in order not to leave the German fire service to come to the incident. This was taken by the police of Airolo, southern side, 5 minutes afterwards of the two trucks, and this is the tunnel. You see that the ventilation works very well. Why? Because see how close this person taking the picture is. But on the other side, we don't know what's happening. And unfortunately, on the other side, there are many people. This is what happens outside the tunnel. And it's what I told you earlier, the ventilation. You see it over the roof, but you see how dense the smoke is. It's difficult to extract all this smoke and clean the environment inside. So losses. All victims were found from the northern side, behind the trucks you saw in the picture. Apart from one driver of the Belgian truck who he decided to go back to his vehicle and he burned there. We don't know what he did that. We had 11 fatalities from toxicity from 12 to 15 minutes from the onset of the fire. We had all these deaths. So after the onset of the fire, they had 10 to 15 minutes lifetime. And this is why we know that this is the time of intervention. So apart from the driver of the vehicle, all the others were found at the full length of the tunnel, and they had passed from escape exits because they could not see. So up to then, all signaling in the tunnel were on the doors. Now, if you go to the tunnels, maybe it's impressive that you have the signs on 1 meter 110 so that people can see it directly from the gaze line, because very quickly smoke will go a little bit over your head. So you can't see the doors anymore and the signs. I have pictures, I wouldn't want to show them here, but I can tell you that the two victims are really, really at the threshold of the door. They really died half a meter away from life because they didn't know they were there.
This is the damage in the tunnel after the fire was put out. So the structure is completely destroyed. This tunnel cannot be operated after this. Damage is 1.2 million euro to repair. So water fire suppression system. There are no sprinklers. There are fire hose reels. You cannot have sprinklers in tunnels for different reasons. Have fire cabinets. I don't know if there is a sprinkler enough to prevent such damage. It's a system that could be helpful and could or not. Um, there are fire safety measures installed in the tunnels. There's water mains, there's fire cabinets. There is an extensive network of firefighting measures if you are able to use them, because then you ask the question if the user, the people who are trapped there, are able to use such systems. Let's look at what the responders did. There was an immediate response from the south, from Italy. The accident was close to them, was 1.1 kilometers from their side. The fire could be fought only from the south side because the smoke was going towards the north. But because of the high thermal load from the fire, what happened is from the north side, they could not go inside and stopped 2.5 kilometers away from the incident at 13 minutes after the onset of the incident. So 30 minutes after the fire started, they were able to go as far as 2.5 kilometers away from the fire, so there was no lag. They could not respond to the incident. So all the interventions and the rescue operations involved about 350 people, 70 vehicles, and 5 helicopters. Now, to conclude, I will just say that we established the white paper on transportation policies in 2010. We had the 2 directives that you see, and in Greece, we've implemented the law with the law decree from 2007. We enforced the legislation and incorporated the European directive in our national legislation.
Σαν δομές.
In general, tunnels are safe as structures in our country. The problems lie in how ready we are and prepared to deal with incidences such as the one described just now. We need to change our mentality. We need to change the procedures to approach, and what I told you before, we need to think outside the box. We need to move away from our firefighting mentality and the things that we use so far, and do something different. Look at the structure and find out what are the elements that we need to use from our tactics in order to be successful in such structures. So we need to have drills, and realistic drills, I would add. We don't need to have drills just to be successful or to have photographs taken and say that, okay, we did fine. We need to have the right exercise, the right drills to pressure our services, our people to fail. Because when they fail, then we will be able to analyze the results and have a positive outcome in an actual event. We need to familiarize our people with those systems. Our people need to be aware of what's in place inside the tunnel. Peter has said something tremendous before, that you cannot be a firefighter and say, I cannot use an SPCA. Unfortunately, I've heard that. The respiratory device is for a firefighter the same thing as his lungs. We lost sound again in the booth, unfortunately.
I think it's an omen.
Όλο. Άσο, ξανά. Σύνδεσε το άλλο.
Ναι, ναι. Κράτα το τώρα και βάλτε εδώ. Εντάξει.
Για βάλτε όπως είναι. Εντάξει, εντάξει. Λοιπόν,
Okay, third time is a charm. Let's go. So, as I said, we should know all the systems within a tunnel and just discover them then, because then it's game over. We have to know all the means of rescue inside a tunnel, but we haven't done any drills about that. We do the drills the same as residential fires. And through the Fire Academy, we are there to write a thesis. We should give thesis to young officers in order to have approaches in order to operate in such circumstances. Then we also need to plan realistically how to face all the risks involved. We need to do organization charts. We need to know the competencies and the role of everyone involved, and we need to have communication plans. This is Peyton, the colonel. What does he say? If everyone is thinking alike, then somebody isn't thinking. So you do understand we must think differently and out of the box, because if we all think the same way, then obviously we're not thinking. Nobody's thinking. In conclusion, I'll stick to what Einstein said, and it's important to tunnels, that whatever counts cannot be counted, and whatever can be counted does not necessarily count. So this is food for thought. We must deal with every incident differently. Tunnels are a different structure from anything we've had to deal with so far. Risks involved in tunnels are too many and they multiply exponentially, so we need to be ready to have planned in advance. And if we are lucky as well, then we may be successful. Thank you.
ακούω ερωτήσεις ή ανησυχίες.
So, Q&A.
Ευχαριστώ πάρα πολύ. Ευχαριστούμε για την...
Thank you very much for the presentation. Congratulations. Well, it may sound ridiculous, but since we have escape exits for the people trapped, why can't they also be entrances for us? They are. So we have no problem reaching. Yes, we can approach them. This has to do with our training. I said that most drills that we do, and maybe you've seen pictures of them, are we reach from one side, we bring the hoses, foams, etc. We take a nice photo, we go to the buffet, we eat our cheese pies, and that's it. But we need to design a drill where you will be in Platamonas, for example. They will tell you to go for an incident at the 2nd kilometer of Tempe Tunnel, direction Thessaloniki. And then they have to revert the whole process of approaching the tunnel. So you will have to use lateral entrances. So use escape exits and make them your entrance and access points. But where do you access? You access there where is the heat load because you're ahead of the fire? Or do you have to go to the next exit in order to be behind the fire? This is why you do the drill. This is why you need to know the structure. And this is the reason why we have tunnels, especially in Tebi, where there are even small doors for small cars. Not just that is escape doors for people, but also small doors for cars, for small cars. You said earlier that we can use the lateral access points. This happens when we have a bidirectional. Yes. What I'm telling you is that most tunnels are unidirectional, but from laterally, we can be helped in order to reach, to access the incident easily. The only problem is to be ahead of the smoke. So we need to have the logic of we should close the door behind in order not to contaminate the escape route of the people. Okay. Well, these compartments that go in and close the door behind, if we have a big vehicle at the other direction, can we close the door? You close the door even though you have your hoses opened up. Yes, as in the apartment, there is a specific gap left with the hose. Same thing here. So if you go and you are behind the fire, there is no smoke. So even this small gap will not bring smoke to you. When we say that we're dealing with and managing smoke, this has to do with the ventilation and it has to do with the direction of the smoke. I have to be from the access point where I do not have any incident and I am safe. Okay? Thank you. As a civilian, not as a firefighter, I think that all this topic is really important. It has to do with the firefighting operation, but it was said here that the bigger problem starts from citizens who are not trained because some of us is the perpetrator of the accident, let's say. Of course, any accident can take place. We all use tunnels. And although that I drive a little bit, I speed, I usually go slower within the tunnels because I know the risk. However, I see people that really are at full throttle inside the tunnels. So maybe we could have some TV spots or some training when people learn how to drive where dangers and risks are explained to them. Because, you know, when you have no idea of the risk, then you still drive fast as you used to. I think we need to become more active and start changing our mindsets from the educational point of view. We know that accidents will happen, but we can reduce the probabilities in order to have less accidents in the next 10 or 20 years. I think we all have a say in that. Okay, Dimitri, this is a significant topic. Maybe for the tunnels, it's something, contemporary. But actually, we can do this about all topics, hospitals, buildings, malls, whatever. I think this individual responsibility is important. We are all responsible individually. If we speed in a tunnel, it's what Kimon said. I speed and I don't wear a belt. It's the same thing. But inside a tunnel, you are responsible for other people's lives too. It's a different thing what I do when I'm on the highway driving alone, and it's a different thing what I do when I drive in a tunnel. Yes, it's true that we don't drive carefully and according to the rules.
Καλά κάνεις.
Αναφέρατε νωρίτερα
You said before that we have reinforced concrete tunnels, whereas in Europe you have stone-built tunnels. What's the difference between those? Is there a difference in the structural strength of the structures? I think our friend from Germany could perhaps tell us. Well, first of all, the stone tunnels are older. In the last 60 years, I would say that every tunnel is made from reinforced concrete. The difference is that concrete has a lot more strength and more strength against thermal load, so it needs more time, a long time burning for the concrete to start failing, which means that we have more time to respond safely. Now, it's up to us. What I told you before, we forget about the attack procedures that I'm trying to put out the fire. We should look at how to cool down the structure. When we did the drill with Kimon at Switzerland, we were going to put out the fire, and they laughed at us, sort of, and then told us what we need to do. You are not interested in putting out the fire. You have to cool down the structure so that you can more easily approach it and help civilians escape. I think there's maybe no more time.
Να σας ευχαριστήσω.
Thank you all.